So let's analyze this circuit where we see all of those passive components such as resistor R, inductor L and capacitor C's are connected in parallel with each other, and the currents flowing through each of these passives are indicated as IR, IL and IC respectively. And that IR, IL and IC, if you sum them all, that makes up the total current that is being drawn by this circuit of passives from this voltage source E, providing a sinusoidal signal to the circuit. Now there are various ways this circuit can be analyzed. We have a total voltage E applied to the circuit, we have a total current I. So the total impedance of the circuit would be the total voltage divided by the total current. I am calling it as a impedance, total impedance ZT. I'm not calling it as a resistance. Why? Because the circuit contains, along with the resistors, you have inductor and capacitors as well, which offer their own reactances. Just like resistor has resistance, the inductance and capacitances, they have their reactances. So the equivalent resistance of the circuit will be termed as equivalent impedance of the circuit. Okay, and that ZT can be calculated, which will be the ratio of voltage divided by the total current. So if we want to know what is the total impedance of this circuit, it would be simply the sum of the resistance R plus the reactance of the inductor, which is J omega L, plus reactance of the capacitor, which is J omega C, 1 over J omega C. So that becomes your total impedance of the network. Now, just like we calculated the total impedance, we can always also calculate IR, IL and IC. So if you want to know the value of IR, you can apply the Ohm's law of Kirchhoff's current law. Would be, we know that I is the sum of IR plus IL plus IC. That is how you, so you want to know any of this component, you should know the total current and other two current values. That's how you can calculate. Let's say you want to apply the current division rule into this circuit and want to know the value of IR. So IR can be calculated by taking the equivalent impedance of L and C. Okay, let's say R, I would say Z equivalent divided by R plus Z equivalent multiplied by the total current I. So now what is Z equivalent? Z equivalent will be the parallel combination of L and C reactances, so which will be Z omega L plus 1 over J omega C, but I have added them in series, they have to be in parallel. So I would write J omega L in parallel with 1 over j omega c. So you just simplify this z equivalent and plug that value right here in this equation. You can get the value of IR. Similarly, what if you want to know the value of IL? So IL can be calculated as, you take the equivalent impedance of R and C, so let's say Z equivalent, divided by j omega L, which will be the reactance of inductance, plus Z equivalent, multiplied it with the total current I, and here Z equivalent would be the parallel combination of resistance and the capacitance reactance. So R into 1 over j omega c divided by R plus 1 over j omega c. So simplify this expression for Z equivalent, plug in that value right here in this equation to get the value of IL. Similarly, you can calculate the value of IC by first taking the Z equivalent of R and L, putting that in the numerator, and in the denominator you will have sum of capacitive reactance plus the Z equivalent of R and L in parallel, and multiplied the total value with the total current I. So this is how you can determine various currents into the circuit. You can calculate the total equivalent impedance, that is ZT, of this network, and you can also calculate the voltages across each of these components. So for example, when the current IR flows through resistor, what you will have is the voltage drop across the resistor, which will be VR, and that can be written as VR equal to IR into R, simply an Ohm's law. Similarly, when the current IL flows through inductor, it will have the voltage across the inductor, which is again Ohm's law, the current multiplied by the reactance of the inductor, j omega L. Okay, or I would say simply, let's say it can be written as ZL. Similarly, VC is the voltage drop across the capacitor when the IC flows through it, and it will be written as IC multiplied by ZC. So ZL is j omega L and ZC is 1 over j omega C. So hope you like this video. If you like this video, please share with others and subscribe to the channel.